Hi all, welcome everybody. Thanks for joining our first event of ThoughtWorks Italy Share It community. So my name is Mario Grimaldi. I am a software developer, and like the other organizer of this event, I work for ThoughtWorks in the Italy office. So I know that you're waiting to hear from our speaker and learn more about domain-driven design. So I'll just steal a few couple of minutes to introduce ourselves. So first of all, who is ThoughtWorks? ThoughtWorks is a global software consultancy, and we love to solve complex problems. Among our different values, sharing is a very important one. We do share in many different ways. We write books. You might know some of the one that you're seeing now on the slides. Articles, speak at conferences. We also publish the Technology Radar, and of course by organizing community events like this one. So what is Share It? What is our mission? Our mission is to build a community in order to empower individuals and organizations by sharing our knowledge based on our own experience. We will touch upon many topics in today's event and also the next one. We will go through architecture, technology, design, agile and team practices, diversity and inclusion, and much more. So, stay connected with our Meetup page where we will publish all the future events. So, let's close the introduction and let me just remind you a very few simple rules of our super simple code of conduct. So in one line, just be excellent to each other. During the event, you will be able to share your thoughts and questions through the YouTube chat. So please be kind and respectful with each other. And remember that we are all here to learn. So don't be shy because any question is a valid question. Now, enough of me talking, let me introduce you our first speaker. His name is Andrew Harmel-Law. He is a tech principal at ThoughtWorks and a domain-driven design trainer at O'Reilly. And today he will share with us his thoughts around the art of domain-driven design. So please welcome him with a big virtual round of applause. And Andrew, I will stop sharing and over to you.
Thanks, Mario. That's brilliant. I'll share my slides. These ones. Okay, so hopefully everybody can see these. If you can't, or if anything's going wrong, please, I know everyone, Mario and Vanessa and Roni, who are looking after me, are watching the chat. So I can't see the chats. There might be a slight delay between asking a question and them getting it fed through to me. But I really would like to hear your questions and your feedback as well. So any feedback that people have would be awesome, but also questions are really good too. The topic I'm going to talk about today is the heart of domain-driven design. So it doesn't have microservices at it, but what I'm going to do is there's a third section to the talk, and at the end I can share all the slides which have all of the speaker notes on them. So hopefully I speak slow enough and clearly enough that everybody can understand what I'm saying. But if not, then please shout in the chat, and also just remember that you can read the script afterwards. So hopefully everything will still be clear. So without further ado, let's go and start talking about the heart of domain-driven design. So first, a little bit about me. So as Mario said, I'm a tech principal at ThoughtWorks, and I've been at ThoughtWorks 3.5 years. But I've been a consultant for 15 years. So during that time, I've worked in lots of sectors. I've worked in the public sector and in the private sector. And I've been doing domain-driven design, I think, for 12 years. It feels like a long time, but it has been quite a long time. But it's been using, for how I've used it has definitely improved my life and definitely improved the software that I've delivered. And recently, because I've been kind of so enthusiastic about it, I've been trying to spread the word about domain-driven design as widely as possible. And that's why, as Mario said, I recently became a trainer on the O'Reilly training platform with a course around about the first steps that you can take in domain-driven design. And the next run of that, I think, is coming up in a few months' time. So if people are interested, then maybe you'd be still be interested after doing this talk. So what am I going to talk about? Well, I'm obviously going to talk about domain-driven design, but domain-driven design is a really big topic. It started off with this book by Eric Evans, published in 2003, And the topics I'm going to talk about, the three things I'm going to talk about, are completely sourced from this book. So I'm not going to talk about all of the other stuff that's come out in domain-driven design. I'm not going to talk about all of the other books that were written by other people. I'm not going to talk about event storming, even though I'm obviously in Italy or speaking to Italy, the home of Alberto Brandolini. I'm not going to talk about any of the things that you hear about at DDD conferences or all of those other things. But I would recommend that hopefully after this talk, you've learned enough, if maybe you've not come across DDD, to go off and look into those things too, because domain-driven design is a very rich area and it can significantly help you solve problems. And that's what I want to talk about is what are the problems that it can help you solve? And it's right there in the subtitle of the book. So it says it's tackling complexity in the heart of software. But that raises two questions. The first question is, what is the heart of software? And Eric Evans makes it very clear in his opening at the very start of the book. He says the heart of software is its ability to solve problems for its user. All other features of software support this basic purpose. So that's something really important to bear in mind. And I think sadly, sometimes we're not so good at this, right? We get sucked into the technical problems and we forget about the business problems. The second question is, where's the complexity? And Martin Fowler, who's works at ThoughtWorks, obviously, he wrote the foreword to the book, and he explains the complexity is the essential intricacy of the problem domain itself. And he means the complexity in the heart, right? The complexity in the business problems, it's the complexity of the problems that our users have that we're trying to solve. And so he doesn't mean the complexities of the technical things. And so that's what this book is all about. This book is about giving you practices, tools, mindsets, approaches, and patterns and techniques to solve these complex business problems in the heart of software. But there's a problem. And the problem is that the book is really thick. And there's another problem, because I've kind of talked about domain-driven design in lots of places around the world, especially outside of the kind of English language speaking world. And it's also not the easiest book to read. So I'll be the first person to admit that, if English isn't your first language, I think it's beautifully written, but it's definitely not the easiest book you'll ever read about IT. And so therefore, that's kind of what I want to talk about in this session here, is give you just enough to kind of get to grips with the core of the book, and then you'll be able to dip into the book and get lots more stuff out of it. So, like I said, I've done talks in the past about domain-driven design. I've done talks about little bits of DDD. I've done talks about big bits of DDD. I've done talks about how I've succeeded with DDD and how I've failed with it. But across all of those talks, and across the O'Reilly training course, and across lots of the sessions I've been to at conferences, are three key concepts. And those three key concepts form a core, and at that core is what everything else in domain-driven design sits on top of. And it's a core which, when you're doing DDD, you come back to these three key things again and again and again. And therefore, if you remember these three key things, and it's easy because there's only three of them, then you'll succeed in doing DDD. And if you forget them, and I know this from experience, then you'll probably fail or it'll get too complicated, right? So what are the three core concepts? The first one is famous. It's so famous, it's got a chapter really early on in the book, and it's called Ubiquitous Language. The second concept is core enough to have a pattern in the book, not a chapter, but just a pattern, and that's hands-on modelers. And the third core concept is everywhere, but it's more of a theme through the book, as opposed to a concept like Ubiquitous Language, as opposed to a chapter like Ubiquitous Language, or a pattern. So it's something which threads all the way through the book, and you can kind of spot when you know that it's there. And that one is multiple models. And so what I'm going to do for the next two parts of the talk, and this is a three-part talk, so we've kind of come to the end of the introduction. What I'm going to do for the next part of the talk is individually introduce each one of these concepts as they're described in the book, right? So I'm not going to go beyond what the blue book says and what Eric Evans says. And I'm going to clarify them and make sure that, lots of us have probably heard of Ubiquitous Language. Lots of us, have maybe heard of some other DDD concepts, but sometimes those things are confused. So I'm going to go back to look at those. I'm going to look at them as well in kind of relation to one another, because they all build on top of each other and they make each other work. And then when we've got that defined, I'll pause at the end of each section just to check everybody's cool with where we are. And if people have questions, then that'll be cool. We can take questions. But when we've finished that, then I'm going to go back around each of them again. And I'm going to share some of my experiences with some of these things, some of my personal opinions, which might not agree with the book. And again, kind of share some hints and tips and things. And again, at the end of each of those sections, if anybody has any questions, then I would be super happy to take questions about that too. And it doesn't need to just be questions on these topics. You maybe have questions on other things. Maybe we might have to park them and we can come back to them at the end. But what I'm going to do is aim to finish at the end of the hour. Finish before then so we can do questions, but I can also stick around a little bit beyond as well if people have questions beyond that. So we'll try and focus on these things here, but then if other people have questions about other stuff, we can get to that too. So hopefully that makes sense. So let's talk about ubiquitous language. So at the very start, I made it clear that domain-driven design is there to help us solve problems in complex business domains. And those business domains are places where our users work all the time, day to day, right? And they're the problems that we're trying to solve and make easier for them. And so to do that, it's kind of obvious, probably, if we think about it, that we need to understand the things that are complex, and we need to understand the domain complexity, because that's where those problems come from, so we can design and implement software that solves those problems. So what might this domain complexity look like? Well, for a good chunk of 2019 and a little bit of 2020 until COVID hit, I was working in Oslo for a banking services provider, and their domain was retail banking. So the reason I picked this example is because even if people haven't worked in a bank, most people have a bank account, right? And that's kind of a universal thing across the globe. So people have a vague idea of how stuff works. So we're going to use this as our example. But what's clear, like I understood a little bit about a bank because I've had bank accounts and I've, had other financial products, but I didn't really understand how banks work. But they had experts who were deeply, deeply knowledgeable about how banks worked, right? They knew not how only banking worked, but how bank accounts worked in different countries because they were in Europe, so they provided different products to different places. And they knew other things too. They also knew about the legal requirements, which they had to meet because they were making a product which lots of other banks would use. And they had to know that how their software would be used by those banking clients. They also needed to know about how EU law changes could affect things and regulations and all of these other things. And they also needed to know, like I said, how not just how their software was used, but also the whole ecosystem of banking and the flows of information and all of these different things. What processes there were, what checks and balances there were, much, much more. So all of this information, and this was all part of the complexity of the domain of retail banking. And so all of this information was there, and it was in the heads of our domain experts. So we had people who were working with us who knew this and understood this. And I mean, that's why they were experts, because they'd spent long enough working in banking to know all of this stuff. They knew all of these details. And the reason they'd become experts specifically was not just because they knew some of the facts, but they'd used all of this information to work day to day and solve problems over many, many years. But the other important thing to bear in mind is this information wasn't just kind of floating around inside their heads in the form of raw data or just pictures like we've got here. What they'd done to make this information usable and to make these kind of mental ideas useful was to pack them away nicely so they could use those when they needed them to get their jobs done, right? So they'd sorted this information, they'd organized it, they'd focused it. And what they'd really done is they'd constructed detailed and subtle mental models from all this information. And those mental models were what they used to kind of guide them through using this information on a day-to-day basis. And where were their mental models? They were stored away up inside their heads. So the domain experts, the people who knew all about retail banking and what problems it needed to solve, they had these mental models stored in their heads. So the key to success for us, from a domain-driven design perspective, is to get at all of that learning, to get at those mental models that are stored up in their heads. And then when we've got at that mental model in their heads, it was to get those mental models into our software. So if they've solved these problems in the models in their heads, we need to get those models out and into models in software and then deliver the software, right? So how might you do this? So you're probably thinking this is kind of obvious, and you're right, right? There's a standard way that we do this in software, and we stand in front of a whiteboard, or these days we stand in front of a mural and we talk to people, right? So we get at them by communicating. So we ask them to explain something and explain how it works. And then we might draw a diagram. So we might be communicating vocally or with words, but we might also communicate visually. And the idea is, as you can see here, the mental model that's inside the head of our domain expert has been transferred to the mental model and into the heads of our developer here on the right-hand side. And then when the developer has that idea, they put that mental model down into the code, into the software. So far, you could say this doesn't feel like domain-driven design at all. This is just domain modeling, and you're completely right. This isn't domain-driven design. This is just good software development. We understand the user's needs and we put them into the software. The domain-driven design part, the first part, is in the language we use for all of these communications, all the way through that thing that we've just showed you. And that language needs to be the language of the domain. And the ubiquitous part of it, the word ubiquitous, is in how widely we apply that language. So this is the first truly powerful concept of domain-driven design. And if you understand, if you forget everything else from this talk, but you remember one thing, it's this thing about ubiquitous language. So Eric talks about it in page 17 of the book. He says, as we talk to domain experts, we rapidly discover their mental models go well beyond find the nouns. So find the nouns is how I was taught to do domain modeling, class modeling when I was at university. It's like listen for the things and turn the things into classes, and then join them up with lines and associations, and then you've got a good mental model. But his point is it's far richer, right? There's far more to this stuff than just that. So how do we get beyond find the nouns? So to get past this, what I want to do is introduce a useful way of thinking about things. What I want to do is I want to suggest that we think of domain experts as developers who can't code, right? So here's Dorothy, who's our domain expert, who knows everything about banking. She's got the best mental models of retail banking that you've ever seen, but she can't write code, right? So she can't write Kotlin or Python or C# or whatever. So she's frustrated. On the other hand, we as developers can write code, right? We're good at writing code, or architects or QAs or BAs, right? We understand the technical aspects, but we know nothing about the domain. Or maybe we know a bit, but we definitely don't know about the stuff that Dorothy knows about, right? She's been doing this for 20, 25 years. So that's the kind of idea that you need to bear in your head. So they're experts, but they can't code in the domain. So they're not experts in code, they are experts in the domain. We are experts in code, but we're not experts in the domain. So something, we need to level this out, right? And that's the thing, we need to level out because it's an unequal distribution of skills. But what we want is a model in software of the domain. So somehow this all needs to come together. And to do that, we need to build a shared model. We need to build a shared model which is explicit, like super clear, and it's explicit everywhere. So to do that, we need to collaborate, and we need to do this as equals. And I think one of the reasons why we fall into traps, and one of the really cool things about DDD, it makes the domain expert an expert at the same level as a software delivery expert, right? That's the important thing. Because therefore, if we get this mental model, we trust and we understand this mental model, and we take it all the way down. We use this with this shared language, which we're taking, right? The language of the domain, the words that the domain experts have in their head. We take that and we put that all the way down to the code. So the idea is that the language that the code is speaking, the names of things in the code, the names of the activities and all these things in the code, is the same as the words that come out of our domain expert's head, Dorothy. So we're going to bridge this. So this is the kind of key first aspect, the fundamental aspect of ubiquitous language. But there's a little bit more to ubiquitous language. So hopefully I've made a good argument for why this communication is super important, because we're sharing mental models all the way down to the code. Almost the model in the code, the mental model of the code is the same as in Dorothy's head. So if this is important, right, obviously this is a high bandwidth communication thing. What we don't want to do is make this a more difficult thing, but we do all the time, right? So how do we make it more complicated? The biggest problem that we introduce is that we translate. And by translating, we fracture our language, right? So we're not aligning our jargon. So there's jargon and, you know, specific words and phrases that are used to describe banking, just like the specific words and phrases that we use to describe software, right? So the thing is, we frequently forget that lots of the words we use to describe software and how we build it, we use it so often we forget that not everyone else understands this stuff. So what I mean is things like words like servers, clouds, database tables, select statements, pipelines, Scrum, Kanban, Kotlin, Go, Node, even microservices, right? These words mean things to us. To Dorothy, who doesn't, you know, is not an expert in IT, you know, what's a database table? Is that like the table I eat my food from? I don't understand, right? So this is the problem. And it's really a problem because instead of listening to the words which the domain experts are using and kind of using them to build our mental models, we use our jargon and we push it onto them. So we make them talk about servers, we make them talk about applications and things, and so we force them to talk like we do as opposed to us talking like they do. And so consequently, what we end up with is a problem because there's a gap now. There's a gap between the mental models and the structures in the heads of our domain experts and in our code and in our heads as developers. And so this is problematic, but it's probably more problematic than you think. So here's an example of something that could cause problems. Here's our first example. So you might hear a domain expert in the language of the domain. They might say, they talk about crediting an account. And what we frequently do, and I know I used to do this before I read about domain-driven design, we don't hear credit account, we hear increment a balance, balance plus plus. So I've translated, right? By doing that, I'm not thinking and not using the mental model of this domain, which I don't understand. I've mapped it onto mine and I'm thinking how I'm thinking. Here's another example. So customers of a bank might open a bank account or open a new bank account, right? But when we hear it, we might think insert into accounts table, right? And the problem is the mental models which we have as developers, these are the things that end up in code, right? Not the mental models that are being used by the domain experts. The mental models that we've used, you know, tables and you know, increments of bounces and stuff, that's what goes into the code. And this translation is weakening communication because we're losing the subtleties and the key small details by doing this translation, right? And that's a problem because those subtleties and those key details are things that we really need to solve the problems of the domain. I mean, what we need to ask is why are balances credited and not incremented? And why are accounts opened and not created? You know, so some people maybe know why this is because you work in banking, but it's interesting to think about, you know, balances are credited and not incremented because a balance is basically the most recent kind of sum total of a series of events, a series of deposits and withdrawals. You know, so if we think of it as a number, we're wrong. We're missing something, right? But if we translate, we never get to ask questions about why these things are different. So we got to stop translating, and that's ubiquitous language. And we need it to be ubiquitous, and this is why we use the word ubiquitous, because we need this language that they use to be all the way, right? So we need to use their language from a domain model and put it in our heads and put it down in our code. So we need to use it in conversations, in documentation, in stories and tests. But I'm going to keep saying this because this is the key thing that you don't see as much as you should, including down in the code. The code needs to use the language which expresses the models. And that's the language which comes from the mental models that are in the heads of our domain experts. So that's it. So that's the first thing. So by using ubiquitous language, we remove the need to translate. So we have richer conversations and we understand these mental models in more depth. And it's important to point out, the language will be spoken, but it might be drawn and it might be written in code, right? A model can be in different ways. It can be a verbal model or a visual model or a code model or whatever, right? So the big thing is for this. And so this is our first step to tackling complexity in the heart of software. So I'm going to pause quickly. Is there any questions for that? This is where hopefully everyone can see or if not, maybe I keep going.
Not so much of a question, Andrew. But
Yeah, cool.
There's an interesting conversation going on in the chat saying, David Laubman says, referring to what you said about the shared model, he says, in the last few years, I've been hearing DDD folks talk about problems and solution spaces, right? Which struck me as going back to Rumble and company.
Yeah.
He says Evans was quite explicit about finding a single model that was understood by both business and tech. He says it's refreshing to hear shared model again.
Yeah.
So, and Christina comments, she adds, we as in developers tend to jump almost instantly to solution space. We have to stop doing it and listen and really grasp the problem before. Yeah,
100%. This is the thing. So depending on if we how much I talk about other stuff, but one of the good things is all of the things I'm going to talk about, you can use if you're a QA or a UX person or a BA or a product person. If you're a developer, you might write it down in code, but other people will think about and express things. And the key thing is, developers, because we are thinking about the solution, sometimes we jump straight into the solution and we forget about the problem space. Whereas UX, QA, and product people are far better than we are at staying in the problem space and really understanding this stuff. So we need to learn from them. If you read the DDD book, it doesn't really talk about anyone apart from developers and architects. But I think if we were good at this as developers, then we wouldn't need the help of people who are collaborators in software development. So I'll go to the next slide. So that was ubiquitous language. So we've got the language everywhere. What a domain expert says, we say, and our diagrams say, and the code says. Is that enough? So no. So the first thing is, remember our idea that domain experts are developers who can't code, and that we can code, but we're not domain experts. Just using what they say is not sufficient, and what we need to do is meet in the middle, because we have expertise, they have expertise, so let's meet in the middle. And this is hands-on modelers. So hands-on modelers pretty much picks up where we left off with ubiquitous language and builds on top of it. And the reason it does is because just traveling in this one direction, taking the information and the mental models from the heads of our domain experts into code is good, but A, it doesn't work, and we'll find out why. But B, we're going to miss out on stuff, right? So, because what we're going to do is, obviously, when we build these mental models in our head and we need to turn them into code, we will encounter problems, right? So you've probably had this before. You speak to a domain expert, you think you've understood them, you go and write some code, and it turns out maybe it doesn't work. So why doesn't it work? Are they wrong? Are you wrong? Did you misunderstand them? So let's look at this, right? So, you take it down to the code and you hit a pain point, you hit a puzzle, right? So what you have to do is you go back to your domain expert and you have a deeper conversation. You ask them to clarify something. You ask them to explain it again because maybe they made a mistake or whatever. And therefore, by doing this, just doing this, we're gaining a deeper understanding of the domain language and especially the models, right? And what we're doing is we're focusing the models and we're sharpening them and we're changing them probably, right? But what we'll also do is uncover complexities and ambiguities in the models, which just by listening to what a domain expert says and writing that down as code won't give us. So you can see here Barbara, the domain expert, has been challenged with a question, and she's thinking, oh, maybe I don't know. I've never been asked this question before. And this is our next quote from DomainDriven Design. This is page 17, really early on again. And it's super true. What it says here is, in having these conversations, you both go on a journey. You as a developer or the architect or the BA or QA or whatever, domain experts are usually not aware of how complex their mental processes are. Because human beings can cope with fuzziness and can cope with imprecision, but you're now trying to make that specific and detailed and accurate. And so what we want to do is kind of have these conversations to learn that, right? And the only way we can do that, the way we do this, is by getting hands-on. So we don't just need to speak the ubiquitous language, but we need to think in it, we need to crunch it, we need to code in it. And who's we? That's us. That's the developers and the architects, right? But primarily the developers. And this is one of my big issues I have with where domain-driven design is seen now. People think it's an architect's tool. It's a developer's tool. Because architects, probably these days aren't writing code. You need to try and take this mental model and write code with it. And then if it doesn't work, then you can learn and feed it back, right? And have these conversations. Because an architect can draw a big high-level diagram and nothing breaks because it's too high level. So yeah, we go back and we have the conversations with the domain experts, right? And so we're making sure the conversations are going both ways. The ubiquitous language is something you build based on the mental models, but you build it with the experts, with the domain experts, right? It doesn't mean that they're completely correct. They might need to kind of change their understanding or hone and refine their understanding, and you might need to too, right? So you kind of come to a shared understanding, you build it together. And if you don't, then you're probably going to end up having problems later on. So just as with ubiquitous language, there's not only one problem that this problem solves, there's also the problem of ownership. So let's talk about ownership a little bit. In software delivery, and it's really pleasing to see that this doesn't happen at Source, because this is one of the things that we do, but there's traditionally been, and sometimes we still see it, there's an over separation of analysis, design, and programming, right? And in 2003, Eric Evans is saying this is a bad idea, and ThoughtWorks still say this is a bad idea. And the reason it's a bad idea, there's always a reason that you would do this. The reason it fails is because details get lost, and hopefully, with the talk of ubiquitous language, you can understand why this is important, right? Sorry, that's a motorbike going past my house. Details get lost when you do handoffs, right? And so you see this in software all the time. And when details get lost, assumptions get made. And as my famous Italian domain-driven design equally passionate person, Alberto Brandolini, has noted, and this is, I think, one of his best quotes, developers' assumptions are what gets shipped to production, right? So it's not what's in the head of the architect or of the BA or of the project manager. It's what ends up in the code that gets shipped to production. And what ends up in the code is what's in the developer's head. So this is the next quote from page 61. So again, really early on. If those who wrote the code don't feel responsible for the model, and this is, the shared model, the model that was represented by ubiquitous language, then the model has nothing to do with the software, because they'll understand the model, but they'll then write something else in the software. So therefore, everyone who contributes to the model must spend time contributing to the code. This is why being hands-on is also at the heart of domain-driven design, because if doing loads of domain-driven design, and I know this because I've failed at this, I've been on a project, I've done tons of domain-driven design, I've cultivated and captured a really, really deep ubiquitous language. I've not passed that down to developers or encouraged developers to work with me on it. So what the developers write has no link to what I've created with the domain experts. So I'd failed by doing that, right? And if you don't get this down into the code, then you're not doing DDD. So that's the second one, which gets talked about less. Ubiquitous language is famous, but people talk about this one less.
So we have one question,
Cool.
Andrew. So there's Chris asking, is there a meaningful distinction between strategic and tactical domain-driven design? Your comment about it being a tool for developer sparked this thought.
Yeah. So DDD is massive. So tactical, I don't think it even got called tactical in the book. This all happened after Eric wrote the book. So this is a really good question. I think he calls the strategic design patterns, which we won't talk about, but we'll talk about enough that you will know where they sit in relation to everything. The strategic stuff is like high level. It's almost project management level stuff, right? It's like how would you gather separate independent teams around a big code base? So we won't talk about it, but we'll talk about multiple models, right? Which will lead into that. The patterns for doing that and doing that efficiently, that's what's called strategic design. It's the second half of the book. I think it's like chapter 14 onwards or 13 onwards. Tactical is the first bit. Tactical is the core bits we're talking about, plus things you might have heard about like aggregates, entities, value objects, modules, and lots of other kind of hands-on stuff, which are very developer-centric stuff. You can do the top level stuff without the bottom level stuff. The strategic stuff without the tactical stuff. My big issue is I think there's a massive power in the tactical stuff, this lower level stuff. And that's where I think it needs to be returned to developers, because people don't think that they can do it, because, you know, you can do tactical without some architect giving you their blessing. You can do tactical level stuff just, you know, in your code base. So it's you don't have to do all of DDD to be doing DDD. You can just be doing little bits. I would even say if you're doing these 3 patterns, no matter what else you're doing DDD. But I don't know if Eric Evans would agree, but I think that. So I'm assuming there's no other questions. I'll keep going. So this is the last bit now. So the first concept was a whole chapter in the book. The second one was a distinct pattern. So Eric's, there's a very, you know, the classic pattern language style. There's a pattern with a name and a problem and a discussion and a solution, etc., etc. The third one is just a phrase that's buried on a page a third of the way into the book. So why do I think, you know, if the first one's a chapter, the second one's a pattern, why is this the third thing? And so my answer to that is multiple models comes directly from ubiquitous language. And the reason multiple models exist is because ubiquitous languages exist. And the first time it doesn't say multiple models, but there's a quote at the very end of the ubiquitous language chapter which makes it clear. And it says, in this chapter, we've only talked about one ubiquitous language, so therefore we've only had one model. And the implication is if you have more than one ubiquitous language, which you totally could on a project, then you will have more than one model. So what does multiple models mean? What it means is when you discover another ubiquitous language, then you have another model. And so this is the next slide is the little detour into this, what I've said is the strategic patterns. If we've got 2 models, it's really nice and, you know, makes your life easier if you've got some nice clean boundaries around about 2 models. And the reason they have this thing called bounded context in DDD is you could, in your imagination, draw a line around one model, which keeps it separate from the other model. And this boundary is bounded. And the context is the context that the language is used in, because that's what gives your, you know, I'm sure in Italian, but definitely in Japanese, right? Different words mean different things in different contexts. So that it's the real world context, right? It's the surroundings when you're using the word. And so Eric, because language is such a big part of domain-driven design, he's taken this and said, right, let's use this as a tool to separate things. So therefore, without multiple models, bounded context would be irrelevant, because we would have just one big model, but DDD doesn't give you one big model. Eric doesn't say that's impossible, but he just says it's so difficult that you shouldn't try and do it. Just accept that there are multiple models which are separate. So the fact that multiple models exist in the simplest projects is probably not a surprise to most developers, right? In many projects, we're aware of them, right? Where things were working really obviously and really well, right? From a development perspective, the data format and the data model of another system, the schema of that database is clearly a different model, right? But that's the easy one, the ones that are easier to spot. What about the ones that are harder to spot? So Eric's got a quote for us here. The quote is, when a discrepancy is not with an external system, so the discrepancy is, it's like the language, you know, when your domain expert is describing things, they may be using the same word for what sounds like 2 different things, or they're using different words for something you think is the same, right? So a good example in banking is you might hear about a transaction, or you might hear about a booking, or you might hear about a, can't remember, but transaction and booking get used a lot in banking. And if you're not trying to split things up, you'll think they're the same thing. But so this is the thing, when you think you're working on one code base, or you think you're working in one ubiquitous language, then it's hard to pull them apart, right? And so if we step back and we remember domain experts frequently aren't aware of how detailed their mental models are or exactly how they work, right? Because they don't have to turn them into code. So therefore, if they're, you know, they have multiple mental models or lots of separate things in their heads, but they don't realize they're separate, then it'll kind of come out as being confused, right? And the way this typically comes out is confusing is when we are standing at the whiteboard and we're having one of these conversations with the domain expert and they're describing things and we're thinking WTF, because, you know, they're describing things and what a minute ago sounded really specific and concrete and detailed suddenly sounds a bit, you know, like it doesn't fit. And what we've happened upon is two separate ubiquitous languages, but they're just smushed together because so one conversation is actually about two separate things. And the reason this suddenly happened is because we have two problems to be solved, which means two mental models, which means two ubiquitous languages. But because sometimes we don't break things up, and we're experts at breaking things up, right? But domain experts maybe aren't, because they just have 3 or 4 or 5 jobs to do, so they just do them all separately. But what we need to do is not ignore the languages, the signals ubiquitous language is sending us, because if we miss on the signals, then we'll miss the fact that things are different and we're splitting them up. So therefore, what we need to do is be prepared for this situation arising, right? When we're drawing a model, we keep the model clean and we keep it focused on a single problem and we keep it distinct. We know where the edges of the model are. And we keep, that's a single model. That's our first model. And what we need to look for is this splits in language. When something doesn't fit with our model and, we hear it in the language, we need to look out for it. So we need to be proud of our language and our models. We need to understand it, protect it, deepen it, right? And then we let this language be our guide. And so we make the most. If we do end up with two models, if it feels like we've kind of hit this point where something is going to have to separate or something is different, then we can use that as a tool, right? Don't try and force everything into one thing, but you can take it and split it out. So that's the multiple models thing. That's us through part 1 of the book. And it's the kind of the black and white rules, right? So a little kind of note from me, you might think like these things don't sound complicated, right? Maybe the multiple models and multiple ubiquitous languages sounds a bit difficult, but I bet if you go to work tomorrow and you have a conversation with someone who knows about the domain, you might be more aware of these kind of strange bits in language. But just because they're easy and simple, we don't see this in software development, right? So so the next bit of the next kind of session, I'm going to run through quickly. And I'm going to stop frequently to get questions and answers, but I'm going to go back around each of these to share some of my knowledge and experience. And like I said, the slides will be made available at the end. So if I zoom through any of them quickly, it's just to get to the good ones, and you'll be able to read all of them afterwards. So, but are there any questions at this point before we go to? Does everybody understand those 3 concepts?
Yes, we do have some questions. There's also cool. Very interesting conversation going on about some.
Very good. I'll read this afterwards.
Yeah, you probably should. So there was a simple question. I'm not sure. The question is the solution space necessarily the same as the technology space? Chris says, I could imagine it also referring to the user experience metaphors.
Yeah. So this is interesting. This is where solution space, problem space, and solution space isn't in the Eric Evans book at all. He kind of talks about it, but it's not explicit. One of the big things that Vaughan Vernon does when he comes along is he separates out explicitly solution space from problem space, which was good, but that then added a big layer of complexity on top of the core domain-driven design stuff. And I think that's one of the reasons why why architects grabbed onto it, because they liked it, and developers were like, this doesn't help me write code, right? I don't know what to do. I think it is, however, really important. So and that's why you craft this ubiquitous language, because ubiquitous language it comes from the problem space, but you're creating this in language first. You're creating the solution space. And also because lots of us work in legacy, and lots of us kind of work in the world of an set of IT systems that are already there. Almost nobody builds completely greenfield, right? So there's always, like we said, there's the CRM system sitting over somewhere, and so the idea of a customer might exist in 7 or 8 places already in your IT estate and your company. So that's kind of the as is, right? That's where you are now. But in the future, you want to move to this thing where you've got a centralized idea of a customer. And so the core DDD book doesn't really talk about kind of how to get to that. That's where you get some of these strategic design patterns and stuff coming in later. So I'd encourage you to read about those kind of things, because they're good, and they talk about, so domains is the kind of and subdomains is the newer language which got introduced to talk about the kind of solution or the as is space, and the problem space is more about where we are now, right? What the existing solutions are doing and what the existing systems are doing with their data models and all that kind of stuff. So it's interesting. You don't need to think about it to begin with, because it will kind of confuse your thing. What you're trying to do is design the software that has the problems that you're solving. But when you get to bigger, more extensive DDD stuff, then it's nice to kind of look at these bigger picture things and use some of the later DDD patterns to navigate your way through this stuff. Hopefully that was clear. And try not to get too complicated.
I think we can move on as
Cool.
we wrote on the chat. We will collect a few more questions.
Awesome.
So,
awesome. Yeah, I'm going to race through the next bit so we get at least 7 or 8 minutes at the end, and then, like I say, I can stick around afterwards as well. So, so there's more than 7 or 8 minutes of this stuff, but I wanted to go, at a good speed to cover this stuff. So now we'll talk about my experiences, my thoughts, and puzzles. So, firstly, we'll talk very quickly about my kind of opinions on ubiquitous language. Number one, very key point. If it doesn't get down to the code, if you don't have the words that your domain expert is saying in your code, in the names of classes, functions, attributes, etc., you're not doing DDD. So I'm not going to hate you for that, but if it doesn't, you're not going to get the benefit. So yeah, make sure it gets down to the code, right? Number two, some people say, do you really need domain experts? Super ideally you do, but I've been on projects where you're lucky to get domain experts because these people are clever, right? They're off, the reason they know all of this stuff is because they're really useful and they understand all of these things. So sometimes you don't get them all the time. Sometimes you get them very infrequently. Other times you get proxies, but this is where we can lean on people like UX, BAs, and QAs, right? People who are very good at spending a shorter period of time than us to really understand domain stuff, and then they can proxy them. So it's not ideal, but it's possible. Next one, where to find domain experts. This isn't in the book, and it just assumes you have an access to a domain expert and you know what a domain expert is. There's a lot of stuff in the notes here about it, and I think I wrote a Twitter thread about it too. But if you're interested, get the link off the organizers afterwards and read about that. There's a lot of kind of patterns and anti-patterns around about domain experts, and sometimes it's better to have no domain experts than someone who's a poor domain expert because they can send you down the wrong path. And finally, what happens if you were so lucky you've got too many domain experts? That's like the best thing ever, because I've had domain experts who've had major disagreements with each other as to how the domain actually works in front of me, and all you do is you give them a pen and you get them to both draw up on the whiteboard or on Mural or whatever, or Miro, what they think the answer is, and then everyone will learn more about the domain because of it. So you might need to facilitate the conversation to make sure they don't hit each other, but it's super interesting. You'll learn stuff, they learn stuff. I had it with 2 lawyers were disagreeing on how the law in Scotland worked, and they both learned something about how the law worked, and I did too because I was just listening. So that's that one. Next up is hands-on modelers. So I've already said it. What about QAs, UX, and BAs? The domain-driven design book doesn't talk about these roles at all, and you could be forgiven if you were, one of these roles for thinking that we developers think you should not exist. If we were good at this stuff, we would have been doing this from 2003, right? But we're not good at it. So therefore, it turns out, I think, that maybe Eric Evans is a super developer or something who can do lots of different roles and different hats. I personally benefit greatly from having people with these different mindsets working on my project, because they can still do DDD as a collective and we can still work together. Number 2, I'm contractually obliged to say this because of ThoughtWorks, but domain-driven design loves test-driven development. The easiest way to get domain language into your code base is to write tests first, right? So you're doing TDD, so you write a test, you write a red failing test, you write that in the language of your domain expert. If you're lucky, you pair with them because maybe they don't want to understand your code base. You can write clean tests, maybe in Cucumber, but you can do it in Unit, JUnit or whatever unit test framework you want to use. You can write tests which assert statements that they believe, and then that will, by accident, your code, these words will bleed into your code. So it's good. So definitely do TDD. Can I do TDD with OO and functional? Yes, you can. So there's a big community about functional DDD, which I've never done, but everybody seems to love it. But you can't do DDD with procedural or data-centric languages. And the reason is, and maybe I didn't make it super clear, but it's worth making clear, it's not just about the nouns. It's not just about the things and the attributes. It's about the problems you're solving. It's about the activities. It's about the logic. The steps that your domain experts take in their head. If you just model something which treats things as a step A, step B, step C, and focuses on the data and the manipulation of the data, you will lose, and your language will draw you into the wrong place. And so that's the first two concepts fleshed out. What I want to do is take a little step back. So we talked before at the start, remember that ubiquitous language fed into Handson modelers. And so far we've talked about commentary on that direction of the loop, but we haven't talked about commentary on the other direction of the loop. And it's the reason I've laid this slide out like this is an iterative process, right? Like software, discovery of a domain is an iterative process. So we need to listen to the language, use the language, feedback in the language, etc. Right? And we do hands-on, and this is how we learn it, right? So it's super important. And the reason it's super important, especially if you TDD, is it's the best way for me is to listen to some language and then write a test based on that language and then run that test and see if I can implement it. Because then you'll get to code really quickly, right? You'll get direct feedback as to whether your models are working. And sometimes things don't work, right? Sometimes you write a test, and if you go to implement it, you realize you can't implement that test without two other tests breaking. And that's good, right? This is not a bad thing. This is good because you're about to have a breakthrough, and breakthroughs is a big topic in DDD. So breakthroughs are also known as, I think this is a quote, when your model makes a sudden and significant leap forward in depth and focus, right? The problem is you can't force a breakthrough, but there is techniques, and this is what I talk about in my O'Reilly course, how to get to breakthroughs as soon as possible. And breakthroughs come from moving away from the data and moving towards the logic and the steps that the business processes that we're trying to support. And so there's two kinds of breakthroughs, right? Sometimes a breakthrough gives us deeper insight, and it just means our model is wrong and we need to refactor it. Other times, our model isn't wrong, but our breakthrough can't be kind of contained within the model that we've got, right? And that means we've discovered two ubiquitous languages. Our model is coherent, but now this test can't fit in this model. So now we've got this idea that we need to split our model. And that's awesome, right? Because this is what we're wanting. We want to know when to split things, and therefore a nice way to do this is to write a test and find out. So what we end up with is two, we split them out, we take what we need from the old model into the new model to support this new kind of idea, this new test or this new 2 or 3 tests, but we maintain the old model, which was working with the old sets of tests. And the reason why we should be able to see the different language, and as you pull them apart, you'll be able to see the language even more clearly, because you can say, when you're talking to your experts, oh, I'm not talking about that bit now, let's talk about this bit. And you can see them in their heads pulling these things apart. And so therefore, we've got our multiple models, and that's how we bring in our third piece. So I've got a few comments on multiple models. Number one, multiple models unlocks bounded contexts. It unlocks strategic design patterns in DDD. It unlocks microservices, which isn't in this presentation, but there's extra slides at the end of the deck if you want to see how you get there. It unlocks independent teams. It unlocks accelerate and the 4 key metrics and decoupled architectures. All of this stuff comes from discovering multiple models, from listening to splitting out separate ubiquitous languages. People then say, what about dry? And what I say is, I would encourage you to go and read a blog post by Matthias Verrees called Dry is About Knowledge. If you Google it, somebody usually Googles it and puts it in the chat at this point. That's it. So we're not duplicating knowledge, but we might be duplicating some attributes and some data, but that's fine, right? Does this mean you can have canonical data models? No, you shouldn't have a canonical data model, because trying to fit all things into one big model will fail. And finally, can you have nested bounded contexts? I hear this sometimes. People say you can have a bounded context within a bounded context. No, bounded contexts are bounded, right? They're next door to each other. They don't sit within each other. That is the end of my commentary on the heart of domain-driven design. So has anybody got any questions or comments or feedback?
So building up to this event, Andrew, we had a few people asking some questions. I don't know if you want to hear those.
Yeah, cool, whatever.
So somebody has been asking me, what do you think about context mapping and how do you think it should be done?
So context mapping is awesome. You don't need to do context mapping to do any of these things. You can use this and because you won't end up with loads of context. Context mapping is good when you get lots of bounded contexts. So when you do event storming, you'll get lots of bounded contexts. When you build a few systems and you're building more and more, or when you've built a few, you build a few microservices, right? To start off with, you've maybe got 1 or 2 or 3. Then you don't really have the complexity to manage, so you're fine. And typically they're being built by the same team. But when you've got multiple teams, and if you go beyond 2 teams, or maybe it's 3 teams, what you want to do is align your teams to your bounded context, and then allow your bounded context, because they're based on ubiquitous language, they will be aligned to your different aspects of your business. So you will accidentally align your microservices to your teams, to your bounded context, and then you get team topology stuff for free. And when that probably gets beyond 3, then it's worth reading chapter 14 onwards, which is strategic design patterns, and doing a context map. But before that, it's probably not worth it, right? Probably everybody can hold all this stuff in their heads. But context mapping, we use it quite a lot at ThoughtWorks to because we go in and, like Vanessa, you and I were working on this project recently. We were looking at a massive big system they'd already built, and we were trying to split it up for them and figure out how we could wrap teams around about it. So it was good for that. And we started with event storming. So not covered here, or I didn't, Vanessa did. I wasn't there. I was in Norway doing this banking system.
This is the life of ThoughtWorks, right?
Exactly right. So yeah. Then COVID happened, and I've been sitting in my house for 1.5 years, or however long it has been.
I have another one which is strictly related.
Yeah.
And again, it came up in conversations when we were talking about this event. So let me just read it up. So when you kick off a project, how much modeling should we do before we start a project? And how do we understand the threshold of just enough?
Yeah. So in the old days, this is another reason why people think DDD is bad. You can get trapped in a world of doing models. The whole point of my O'Reilly course is we do as little as possible and we get to code as quickly as possible. And it's interesting, you do event storming with Alberto, and Alberto needs to pay me after this. You do event storming with Alberto, and he says, people say, when are we going to document this architecture? And Alberto typically says, he's told me, why wouldn't you start writing code? Is there not enough here to go and start writing code? And that's it. And the thing is as well, right? If you're doing TDD, if you're doing continuous delivery, if you're doing, the smallest thing and then iterating on it and refactoring it, then you can just iterate on it and refactor it, right? So why wouldn't you go down to code? So I might still go through, because I'm old, I might still draw some, a few case class diagrams and just kind of, draw some stuff out. I will now try to get to code as quickly as possible, really quickly as possible. And there's a concept in DDD, which is Eric's concept, but came out after the book, and it's called the modeling whirlpool. And he's like, you do all of the steps that you might do in the old way of doing software, but you go around it really quickly. So you just and you're rough and you're sketchy and you do all that. And the last thing that's kind of in my DDD, the hands-on training course, is we talked about breakthroughs, and breakthroughs is a nice way to use TDD to get to multiple models. There's tricks and techniques, and they're even in the Kent Beck TDD book. He's like, you don't want to write a test which proves what you know. You want to write a test which will challenge what you think you know. It's the same thing, right? Don't prove what you know, challenge what you know, and then you'll find out, something that's still true. So a domain expert needs to think it. But if they're like, when does this not work? Tell me this, not write a test. And maybe your model gets richer, or maybe your model splits in 2. So that's good. So you get used to it. You get better at it the more you do it.
We have a couple more observations or considerations. Not really, but somebody says, which is really interesting, at The Guardian, we had editors sitting amongst the dev teams. At one point, one of them interrupted a discussion I was having with my pair to explain where we were confused.
Yeah, this is awesome.
Yes. So, sorry, just to go this out. So, David says he disagrees that you can't do it in procedural or data-centric. Sure, you need to be careful of anemic models, especially semantics, but you can certainly express DDD models in C. That's what he's saying.
Oh yeah, sorry. So you could. So it's really interesting. So, and this is possibly why the book is long. So I'm being a bit. I'm trying to. Because I work for Source. I'm trying to be mildly controversial. Eric, he doesn't say you can't have a single model, for instance. He just says it's so hard that it's a waste of time. He also, when he talks about, and he talks about this in aggregates, and he talks about this in various other various other patterns. You can do it with those things, as long as you avoid anemic things. Eric's point, however, is you need to consciously be on your guard, because the language will make the things you don't want to do easy and will make the things you ought to do hard. So if you're on top of your game, then that's cool. You totally could, right? But the thing is, you want to pick something, and this is why I think functional is quite nice, right? Because functional is it's very focused on the composition of kind of units of not units of functionality, because that's wrong, but you know what I mean. A function is a thing. You ask it to do a thing, and it give it input, and it gives you output and stuff, and it's quite solid and predictable. I think that works well with DDD as well, because it stops you thinking about the data, or you think about the data and the function separately, and you kind of can't have one without the other. So you totally could. You could do this with C, and it's definitely not an OO thing. So you don't. If people think, oh, I don't know object orientation, I don't need to do it. I've seen there's a big PHP community around DDD, which is bizarre, but there is. So yeah. But the thing is, and this is like Eric says, and it's in the book over and over again. He talks about it a lot, because his whole point is making life easier for developers to lower cognitive load and all of this stuff, right? He's like, if the pull of your language or your technique or your framework is kind of pulling you in one way, but you don't want to go that way, then, you've got to actively pull against it. So if you can avoid it, pick a language which doesn't make you do that, right? So yeah.
Then we have a quick question from Alessandro, who asks, what is the difference between bounded context and subdomains?
So, right, this is good. So I only recently figured this out. So if you don't know the answer to this question, this is fine, because I've got a course in O'Reilly, and I only figured this out after I taught the course in O'Reilly. So I've talked before about domains/subdomains, which are basically the same thing. It's just which level you look at it. So subdomain is a good thing to talk about. Subdomain is conceptual and in the business space, so isn't constrained by technical systems, right? So that you have a subdomain which is like customer or inventory or general ledger if you're talking about banking, right? So maybe if you're lucky, that's a one-to-one mapping. It completely overlaps, right? So so you've got your bounded context and your subdomains aligned. So they're the same thing, and they're almost the same thing, right? Or maybe your subdomain has multiple bounded contexts, but none of them cross the lines, right? They all fit nicely together in this subdomain. Winning. That never happens. So what you typically see is the concept of general ledger is mostly, it sits inside this thing, but also a little bit of the concept of general ledger is in, I don't know, some currency processing system, and it's in a reporting system and a bunch of other stuff. So therefore, you need to kind of bring in bits. The idea from a subdomain perspective is actually spread across a bunch of systems, but it's not all of the reporting system. So it's a little bit of the corner of this system, and it's a little bit of the corner of this kind of payment processing system. So then they're not aligned, and that's where, if you look at the Vaughan Vernon book, there's some, I think, bit complicated diagrams, but he's trying to make the point that when things stop lining up and it looks like a bit of a mess, then you're in trouble. So the goal should always be, I have learned, aim to align your subdomains and your bounded contexts, because then you're winning, because then you're super talking about the same language with your business. So if you're doing new stuff and there's patterns to do it, like bubble context and things, protect stuff, make a nice clean model, keep the famous anti-corruption layer, keep the the old legacy stuff, which is a bit messy and not really lined up and a bit doing 7 things when it should only be doing 1 thing. You can keep that at bay and build a nice clean implementation all on your own. But again, bubble context is not in the book. It's Eric talk. He's the white paper afterwards. So hopefully
I have one more question, if you can.
Yeah,
so Andrei Nitescu, I hope I've pronounced it right, asks, what's your next DDD course on O'Reilly about? So wishing for the future.
So this is good. So I've pitched multiple things. You can ask Vanessa if the first. So one of them was, I told O'Reilly that, so my last client where Vanessa and I were, we ran a DDD reading group because my course covers these 3 things, right? But this isn't a lot of the book. There's a load more of the book. So we then did a DDD reading group and they seemed to think that was quite a good idea. And the idea would be we'd kind of read a chapter a week and then we'd all get together and discuss it. So I think that's quite a good idea. There's another pitch, which is there's chapter 10, which is called, I'm going to look at my book and find out what the chapter is called.
The book club was really, really good, just for reference, as somebody who
it was good. And I learned, right? Because I thought there was stuff I would say which was wrong. So I discovered. Chapter 10, Supple Design. Supple Design is, I would call it guerrilla DDD. If you're here, you listen to this, you think this is awesome, but you know that you're going to go back and your manager, like your tech lead or whatever, is never going to let you do this. You can go and buy the book, read chapter 10, maybe a few bits before it, right? But chapter 10 is zero permission, how to make your part of the code base better. Because it's things like, it's an excuse to give your methods your functions good names, right? No side effect free function. So it's very functional. It's very interesting. The chapters look like a bunch of functional kind of concepts. No one is going to hate you because, well, if someone hates you after this, then maybe you should look for another employer. But like if you change the name of a function from one or a class from one thing to another, unless you're, hopefully you're using Git, right? So it can cope with renames. Don't do it on Subversion because it'll be a disaster. But if you change the name of this thing or this function to be closer to the words that the domain expert uses or closer to the business domain, I really don't think someone's going to hate on you for that. And chapter 10 is all about that. And then you're like, oh, look what I've done. Look at this little bit of the code base has just got a little bit nicer, a little bit clearer. I changed the name of this and suddenly it became clear, which is, clean code. It's doing 2 things, right? So I can't give it one name. This function is doing 2 things. Split the function into 2 functions. And then, then Vanessa and I have talked about this a lot. There's a lot of overlap with with clean code. It's basically just like an excuse to do clean code. Lots of this stuff. It's like, why should I, do this? Why should I do that? Oh, Ubiquitous language said I should do this, which is the business person said I should do this.
Also, I think the last example you used overlaps nicely with Michael Feather's book. What's the title?
Working
Something
with legacy code.
Yes,
yeah,
that one.
Yeah.
So that was the last question, I think. So I think Mario will wrap up.
I need to stop sharing, Mario.
Oh, yes. Thank you. We could use some slides. Okay. Let me share again. Okay. I hope slides are visible. So thank you again, Andrew, for this super interesting talk. Just a few information for closing and wrap up the event. So as we told before, we are also already planning for the next event. So we already planned for a new one, which will be on the 24th of June. This time Matteo Di Tucci will talk us about onion architecture. So if you're interested, please subscribe on the Meetup page. We are going to publish the event in the next days. And feedback. So very, very important. Feedback is a very important part of our organization, of our culture, and we would love to hear your feedback around whatever aspect you want to, share feedback about related to these events. So, the organization, the timing, the way we are sharing our video, the live stream, whatever you might have in mind, please feel free to share that with us. We are going to share with you a URL for a Google form. So I think we are going to share it in the chat now and also in the next days through mails in Meetup. So please feel free to send us your feedback. I think we're coming to the end of this first event. Thank you everyone for joining. Thank you, Andrew, for joining us in this first event. And thank you also for all the people that were sparking super interesting conversation and questions in the chat. So I think we are closing this. So thank you, and see you at the next event.
Cheers.
Thank you very much.
Bye.